I wanted to do a series of videos just addressing the most missed problems in the last quadratics test. And these are kind of in no particular order, but I want to say that this problem number 11 was probably the absolute #1 most missed problem on the entire test. So it's definitely worth going over. It's asking, what are the complex solutions of x squared minus 2x plus 8 equals 0? There's two really good ways to solve this: completing the square or to use the quadratic formula. Let me go ahead and do completing the square in blue. So for completing the square to work, normally what we like to do is like to get all our x terms together on one side, x squared minus 2x. We like to get the numbers or the constant on the other side of the equal sign. So let's subtract 8 from both sides. End up getting x squared minus 2x equals -8. Now the entire idea of completing the square is saying, what number do I need to add to this expression, x squared minus 2x, to make it a perfect square trinomial? And we'll write that as plus a blank right now. There's an easy way every time to figure it out. I want to note that whenever we add something to one side of an equation, we have to also add it to the other side. So go ahead and put plus blank on the right side too, just to remind yourself. This number, which completes the square, is always found by doing two simple things. You take your middle term, or your b value, you cut that in half, and then you square the result. Half of the middle term is -2 divided by 2, which gives me -1. Half the middle term squared, -1 squared, which is +1. So this number I need to add here is a +1. I have to add to both sides. Now, there's some shortcuts we can take here. This half number, the half the middle term, is always what goes inside your parentheses when we write this as a perfect square. And we want to write that as a perfect square so that we can just take the square root and be almost done. Half the middle term squared is we have to add here and to both sides in order to balance it out. So -8 plus 1 is -7. For this equation, I solve it by taking the square root of both sides. Remember that we are taking the positive and negative square root of -7. So this evaluates to just x minus 1, as these two cancel. And this, you use a property of the imaginary unit. This results to I times the square root of 7. To solve for x, you add 1 to both sides, and we get x equals +1 plus or minus I root 7. So that's how we solve it by completing the square. The answer is D. Say you're given quadratic formula. You're saying, well, maybe you tried this and it didn't quite work. Maybe a simplification error, an error in simplifying. -b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. And if we identify our a, b's, and c values, let me go ahead and switch colors here because I'm doing a new method, brand new work. So my a value, since this is in standard form, is whatever's being multiplied by x squared. In this case, it's just 1. Your b is your middle term, or what's being multiplied by x with the sign, so that's -2. And your c value is your constant, that's what's being just added to the end, which in this case is +8. Plug all these numbers into the quadratic formula, so you get -b, or -2. -2 plus or minus square root of -2 squared minus 4 times 1 times 8. This is all divided by 2 times 1. First thing I always want to do when we're working with quadratic formula is evaluate what's underneath the radical. We usually call that the discriminant. And then we'll do a little bit of simplifying along the way. So like things like this. -2 we know is just positive. Okay, plus or minus stays there. The square root's going to stay there as well, because I just want to evaluate what's underneath the square root. I don't want to actually take the square root yet. So -2 squared is 4. it's really saying 4 minus 4 times 8. And if you evaluate all that, you get minus 28. Square root negative 28 over, and then 2 times 1 is just 2. Now here's the trick with this, because it doesn't look like this yet. But here's the trick. Well, for one thing, we can simplify this square root right here. So 2 plus or minus. Remember the product property for square roots. So this can be written as the square root of the products here. Let me find a perfect square. So 28 is the same thing as 4 times 7. This is square root of 4 times square root 7 times square root negative 1. It is negative 28. So if you multiplied all these things together, you would get this negative 28. Underneath the radicals, you would get negative 28. So let me simplify by evaluating. The square root of 4 is 2. The square root of negative 1 I know is I. And this is the square root of 7. And all of this is being divided by 2. Well, one thing we can also do to simplify it the furthest down is split it into 2 separate fractions. So this becomes 2 over 2 plus or minus 2i root 7 over 2. You split it up into 2 fractions that have the same denominator, but the numerator becomes split. And then you can simplify. 2 over 2 is 1, positive 1, plus or minus, and then these two 2's will cancel out. So you get 1 plus or minus I root 7, d. New problem. Okay, well this problem, to be honest, was not missed all that much on the test, but I did want to review solving these systems of equations by graphing. And whether it's in y equals form or not, we need to make sure that if we get into y equals form, we can graph the two equations, find the points of intersection, and those are your solutions, and those are always going to be ordered pairs. So let's start graphing. You know what, let me go ahead and color code this. So I'm going to graph x squared minus 4. I'm going to graph x squared minus 4 in blue. X squared minus 4 is the parent quadratic function, but it's translated down 4 units. So honestly, what you could do is you could put that into a graphing calculator, get a table of x and y values. You will find the point of 0, negative 4. You should also have the point positive 1 and negative 3, as well as negative 1, negative 3. We have 2 roots at negative 2 and positive 2, which also can be seen because if you put a 0 in this equation, 0 equals x squared minus 4, solved it out, you would get the values of positive 2 and negative 2. Let's graph 2 more points on this. So we go up 9 units, and to the right and left 3 units. That's your basic parabola with no stretch factor. Let's attempt to connect the dots here. Ooh, imagine if that's a parabola. Let's graph this in red. And this is a good review. Let's not forget how to graph a linear equation, even if we don't have a calculator. So we know the slope for this is the number next to x, so that's positive 2. And the y-intercept is 0, negative 1. That's based on y equals mx plus b, that basic pattern. So your intercept is at negative 1, so you start graphing here, negative 1. And every other subsequent point is found by traveling up 2 units and to the right 1 unit. Up 2 over 1. And here we go. Here's our first intersection point. It is at the point 3, 5. So we continue that line. But here's your other intersection point. It does occur at negative 1, negative 3. Our 2 answers for the 2 solutions for the system are negative 1, negative 3, as well as 3, 5.